And at fives, so we are still on absorption of materials. We're looking at gas exchange. This is the first of the two that you need to know in real good detail for exchange surfaces. So our main surface for gas exchange is the lungs. That's nothing that should surprise you. You definitely know that. Okay, and the two gases that we're talking about here are oxygen in and carbon dioxide out. So our lungs are, we obviously have a right and a left lung, and each lung is made up of lobes, these bits that are kind of look like they're kind of separate sections. And you can actually have some of these removed. It's not a great thing, but if you have people who have these removed for reasons normally of disease, quite often cancer might cause damage to a lung. So what we have is a single tube starting at the top, and that is the windpipe, also called the trachea, and that's held open by these rings of cartilage. So cartilage is not as inflexible as bone, but flexible enough that it can kind of give when your neck moves back and forward, but certainly strong enough to snap these open. So they're actually not full rings. If they're almost more like a horseshoe shape right the way round to the back. So the stuff that holds your ears in the shape, that's cartilage. And then you come down and it splits into two, one going to the right lung, one going to the left lung. Okay, each of those is the bronchi, so singular is bronchus, sorry, and you've got a right and a left. And then once you get into here, you branch even further. So that big tube then gets broken down into lots of smaller tubes, and smaller and smaller and smaller and smaller and smaller. Okay. So when we zoom in, you can actually see, so here we've got, again, here's our windpipe, here's our bronchus, here's bronchioles. Bronchioles are branching and branching and branching, and if we zoom in, here's a bronchiole that's branched eventually down into what kind of looks like bunches of grapes. Okay, and each of these little grapes is an air sac. Okay, and each of these air sacs, posh name is alveolus, or alveoli if we're being plural. Each of them has a blood capillary that's going right past it, so that it can bring in the carbon dioxide rich blood that it wants to get rid of the carbon dioxide. Carbon dioxide can go out, oxygen can come in, and then it can go back to the heart. So in terms of exchange, we've got two, both of them biodiffusion. We have oxygen going in and carbon dioxide going out. Oxygen being into the blood and carbon dioxide out from the blood. So here's our alveolus, here's our blood that's coming round, and here's the carbon dioxide that is going out into the lungs again, and here's our oxygen that's coming into the blood from the lungs. And so all we have is fresh air comes in, do the exchange, and then push it back out again. And you're doing that several times a minute without even really being aware of it. It is efficient because of those things that we said in the last one, what you're looking for. It's got a huge surface area. Now, quite often you're said things like if you opened out every alveolus in your body, your lung surface would be kind of tennis court size. It's huge. 1 cell thick, which is obviously as good as it can get, and good transport system. Well, every single alveolus, and this is maybe a nicer picture because it's in 3D, has a whole section of capillaries right the way over the surface. And then just to extra help that's important, they're coated in a kind of thin layer of mucus, which helps the gases dissolve, and that means that you can move them as well. So overall, you have a very efficient system, a very nice, good, efficient system for making this work. You do have to be careful with your lungs because they are a kind of one-way system. Like they only come in as far as your air comes down to here, and now you've got to push it back out again. So you don't want lots of stuff to come in and get stuck inside your lungs. So you actually have at the back of your windpipe on the trachea, you have, if this is the outside of it, inside here, you have a layer of cells which have tiny little hairs on them, and they also are kind of goopy, so you've got kind of mucus on the top of here. So anything you breathe in that shouldn't go into your lungs gets stuck on the sides of the windpipe, and then these tiny little hairs push it back up the way. So the mucus then ends up at the back of your throat, and then you swallow it basically and goes down into your stomach. But that's an aside.